Okay, let's look at one of these word problems that is going to involve rational equations. Okay, we're going to be setting up a word problem. So this says that Eileen and Ben, what do? They are in a paddle boat that can travel 8 miles per hour in still water. If the boat takes the same amount of time to travel 3 miles upstream against the current as it does to travel 5 miles downstream with the current, find the speed of the current. Okay, so since we don't know that's what we're trying to find out. That's our variable because that's our unknown. So we're going to say that x is the speed of the current. Okay, and if we draw a picture, here's my river, here's my boat. My boat can go 8 miles per hour. And if the current is pushing it along, what happens to that 8 miles per hour? It adds it. So it's going to add to that rate. And it's able to go 5 miles up with the current. Then you have the situation where here's your boat. Now you're trying to fight against the current. So the current is going this way. You have 8 miles per hour in your boat. Okay, and what happens to that speed? It minuses. So it's going to make your speed slower, and you went 3 miles. Okay, so the best way to set this up is to organize a table. So we have with current, and we have against current. Okay, and we can think about the 3 different things going on here. You have the distance, the rate, and the time. Now, usually you think about distance equals rate times time, okay? But what if we were to rearrange that and I were to divide the rate into the distance? So if I have distance divided by the rate, that's also going to give me the time. Do you see how I just took that formula and rearranged it? It went from a linear equation into a rational equation. Rational because it has a fraction now, right? So the distance with the current we were able to go was 5 miles. And then the rate was 8 plus x. Does everybody see where I'm getting the 8 plus x from? Okay, now check it out. If I took the distance and I divide it by the rate, I get the time. You see that? So I take the distance 5, I divided it by the rate, x plus 8, and that's going to tell me how long did it take me to go. Like you think about miles per hour, right? Now, against the current, we know the distance we traveled was 3 miles. The rate was 8 minus x because the current slowed us down. And so we went 3 over 8 minus x. That's the time it took us to go the 3 miles. Now, what do we know about these 2 times? It says in the problem, the boat takes the same amount of time to travel the 3 miles upstream and the 5 miles downstream. So the times are equal. So what would the equation look like? That's exactly right, because the times are equal, okay? Now, there could be a couple of different ways to solve this, but we could multiply both sides by the LCD. That's going to be our most tried and true way of doing it, and it will prevent any kind of mistakes that could happen from misconceptions. So what would the LCD of the equations be? Exactly. So if you multiply this side by 8 plus x times 8 minus x, and you do the same thing on the other side, 8 plus x, 8 minus x, then what cancels? So you're left with 5 times 8 minus x equals, and then what cancels over here? Yep, and then we have 3 times 8 plus x. And what should I do to solve now? Yeah, distribute. So we get 40 minus 5x equals 24 plus 3x. What should I do next? Sure, we could do that. I usually like to get my x's on one side, and I prefer to have positive coefficient. So I might start by adding 5x to both sides so that I could have a positive 8. I have 40 equals 24 plus 8x. And now what? Don't I subtract? Could I subtract the 24 from both sides? And I would get 16, is that right? Equals 8x. And then if I divide both sides by 8, I get x equals 2. So x equals 2 is my answer, and then that means that if I want to answer the question using a sentence, I could say, what's the answer to the question? The question was 2 hours. Is that right? 2 hours? Is that the time? Or what did x stand for? If we go back to the original problem, we said we set x to be the speed of the current. So how fast is the current then? 2 miles per hour. So the speed of the current is 2 miles per hour. And we could also check this, right? So if we go back, we could say, okay, if I have a distance of 5 miles and it took me, 8 plus 2 is 10, is that going to be equal to 3 miles at 8 minus 2, which is 6? Are 5 tenths and 3/6 equal to each other? And they are. Yeah, they're both equal to 1/2 equals 1/2. And so that means that the time, it looks like it took them, if the distance divided by the rate is the time, is that half an hour? Okay. Well, let's actually stop this one, and we're going to do the next one in the next video.